Alright, so in this video we'll work through the Chapter 8 practice tests, and you can see the topics listed right there. Most of the chapter has to do with rational expressions, meaning expressions that are kind of like fractions, except instead of having only numbers, a lot of times you'll have polynomials, things with x's and other variables. So we'll talk about all of these topics: multiply, divide, add, subtract, solve equations, and also the graphs in sequence. Alright, so for these types of problems, for number 1 and 2, what you need to do is see if there's anything that you can factor, and then once you factor it, you'll be able to cancel things out. Okay, the other thing is when they say excluded values, that refers to things that would cause the denominator of a fraction to be 0. Those are excluded because you can't divide by 0. So let's start by factoring the top right here, and we want numbers that multiply to this 2 and add to this 3, and that's going to be 2 times 1 and 2 plus 1. So that's how the top factors. The bottom will factor things that multiply to 3 and add to 4 would be 3 and 1. And then as we can see, the excluded values, if a equals negative 3, that fraction will be 0. And if a equals negative 1, that fraction will be 0. So 3 and negative 1 are excluded. And then if these cancel, which they should, you're left with a plus 2 over a plus 3. Okay, so actually I think I misspoke. A equals negative 3 would be excluded, and a equals negative 1 would be excluded. I don't know, might have said the positive versions of those, but those are what would cause the bottom to be negative. Sorry, to be 0. Okay, so this one right here, we can always start by seeing if there's a common factor that we can pull out, and in this case we can pull out a 2 from all of those numbers. So 6p squared divided by 2 is 3p squared. 10p divided by 2 is 5, and 4 divided by 2 is just 2. Okay, same thing on the bottom. The bottom has 4 going into all of those numbers. So if you divide each of those numbers by 4, you would get what you see right there. And then the top, actually, the 3p squared minus 2, that actually factors even more. And you can do it two ways. You could do it by guess and check, or we can use what's called the swing method, which means that we would take this 3 and swing it over here. And so we would end up with p squared minus 5p, and then that 3 times minus 2 becomes a minus 6. What numbers multiply to negative 6 and add to negative 5? That would be negative 6 and positive 1. And then remember that 3 that we swung over, that is in the 6, it's now in each of these numbers, so we need to remove it. So p minus 6 over 3, that would be p minus 2, and since we can't reduce that 1/3, we would just take the 3 and swing it in front like so. So now remember, this 2 needs to still be here, so the 2 times and then this thing is what we ended up factoring it to. Let's start by looking at the excluded values. That's the things that make the denominator 0. So right here, actually we haven't totally factored the bottom, so let's do that first. So the top is going to stay the same. The bottom, we are looking for numbers that multiply to negative 2 and add to, that's a negative 1 right there. And the numbers that do that would be negative 2 and positive 1. Okay, excluded values would be p equals 2 right there and p equals negative 1 right there, because that's what would cause the denominator to be 0. Okay, you can see that these will cancel. The 2 will cancel, and that 4 will become a 2 if you divide each of those by 2. So you're left with 3p plus 1 over 2 times p plus 1, and that's option C. Okay, number 3, when we're dividing by a fraction, that's the same thing as multiplying by the reciprocal. And the kind of saying that some people use to help them remember that is copy dot flop or copy dot flip. It basically means you copy this, you make a dot for multiplication, and you flop that so you're dealing with the reciprocal. Okay, the only things that cancel here are 3 goes into itself once, and it goes into that once also. And then, so we have 2 times 1, which is just 2. And then we have 3 times 1, which is 3. And we have p cubed times p to the first, which is p to the 4th. And that's as simple as we can make it right there. Okay, this one's a little bit more complicated, but at least it's multiplying, so we don't have to flip things. So what we should always do is see if there's a way that we can factor, and almost all of these problems you can factor. So on the top, what multiplies to negative 12 and adds to positive 1? That would be positive 4 and negative 3. And we need to put the ends right there. On the bottom, what multiplies to 8 and adds to 6? That would be 4 times 2 and 4 plus 2. So that's what we have right there. And then to simplify, we just see what we can cancel. So there's an n minus 3 that will cancel. There's an n plus 4 that will cancel. And that's really all there is. So the top is just 6n squared. That's all that's left on the top. And the bottom is just n plus 2. Okay, one thing I want to mention, a common mistake, is people will say, well, can't I go like this? Can't I cancel these n's or something? And the answer is no, you can't. And I'll show you why with an example from numbers. If you're ever not sure if something works with variables, test it out by plugging in some numbers and see if it works. So here's the wrong way to do this. Okay, I'll do the right way first, and I'll show you the wrong way. So the right way is to say, well, 1 plus 3 over, let's say 1 plus 6. 1 plus 3 is 4. 1 plus 6 is 7. And that is the correct answer right there. Okay, here's the wrong way to do this. Imagine that we say, well, 3 goes into itself once, and it goes into that twice. 1 plus 1 is 2, and 1 plus 2 is 3. Clearly, 2/3 is not equal 4/7. The reason you can't do that is because when you're canceling, I keep saying let's cancel things. What does canceling mean? It means dividing. If you're canceling something, that means you're dividing, and you can only do that on the opposite math operation. The opposite of dividing is multiplying. So you could do this. If it were 1 times 3 over 1 times 6, then you could do that, and you can test this. You'll get the same thing. 1/2 is the same as 3 over 6. But in this case, we're not dividing, we're adding, and the opposite of adding is not dividing. So that's why you're not allowed to cancel those things. Alright, these are done similarly. So the first one will factor anything we can factor. So right here, the common factor of those two would be 4a, because 4a goes into both of those. 4a goes into this, a times. We're just dividing 4a squared by 4a. And 20a divided by 4a is 5. Okay, on the top, what numbers multiply to 5 and add to 6? That would be 8 plus 5 times 8 plus 1. And the bottom right here, again, this has a common factor of 5. If you divide 5a by 5, you get a. If you divide 15 by 5, you get 3. So that's what we have. Now the question is, what, if anything, can we cancel? There's almost always things that can cancel. The a plus 3's will cancel. The a plus 5's will cancel. Let's see if there's anything else here. Could be, so that becomes a 1, by the way. So let's just make sure it's common to forget things. So we'll take care of the 1 times 8 plus 1. That will be 8 plus 1. So we've covered everything on the top because that cancels. We need a 4a down here. That's done because we canceled it. That's done. But we do also need the 5 there. So 4a times 5, that would just be 20a. So a plus 1 over 20a. Hopefully that's the right answer. And it is. Alright, this one right here is a little bit of a mess, but we can always start this by factoring whatever we can factor. So let's start at the top. All three numbers in the top have 2 going into them, so 2 times this. If we divide each of these by 2, that's 3n squared. That's 22 divided by 2 is 11, and that's going to be 10. Okay, now the bottom's a little bit tricky, but let me suggest something. First, let's factor out a negative, and then we could do this 2 ways. We could use the swing method, but that's going to be kind of a little bit longer than needed because 9 times 25, it's 225. That has a lot of factors. So here's a better way to do it, and you kind of have to notice this. Notice that the number 9 and 25 are both perfect squares. And that kind of looks like something that you FOIL that's a perfect square. So let's try it. So 9n squared, we could have gotten that with 3n times 3n. 25, we could have gotten it with 5 times 5. And then how will we get a minus right there? Well, they would both have to be negative. And if you actually FOIL out what we just wrote there, you can see 3n times negative 5, that's negative 15n. That's inner terms minus another 15n. Minus 15n times minus 15n is minus 30n. So that's a little bit of a trick. You kind of have to notice it, though. It's not obvious when you first see it. But oftentimes, if you have something that's a large number like 9 and 25, where the swing method would be pretty cumbersome, a lot of times that means that that's some sort of perfect square. So you can always try that. Okay, the top, we need to get 3n squared. The only way to do that is 3n times n. We could use the swing method, but just to save some time, I believe this is going to be minus 2 and minus 5. And sometimes if you've done a lot of these, you can do it by kind of mental math or trial and error. But 3n times negative 2 is negative 6, and that's negative 5. Negative 6n minus 5n is what gives us that. And then, of course, negative 5 times negative 2 is that. Okay, so then before we flip this, let's factor the other side. Those all have 2's going into them. So if we divide out the 2 from 14, we get 7. From 20, we get 10. And then same thing here. If we factor this, we could always use the swing method, or we could do just kind of a guess and check. So first of all, since the 5 is negative, that means one of these has to be positive and one has to be negative. And I believe, if I'm not mistaken, it's going to be 5 times 1. Let's just think about where the plus, so this has to be the bigger number. So let's try this. Let's try minus 5 plus 1. This is going to be minus 5n. That's going to be plus 3n, which would give us negative 2n. So that works. Alright, so now our task is to rewrite this in a neater form. So the top of this fraction right here is going to go here. So we have 2 times 3n minus 5 times n minus 2. And then the bottom is this thing, and let's not forget that negative sign right there. So 3n minus 5 times 3n minus 5. And then because we're dividing right here, we're going to have to use that acronym copy.flop. So we'll copy this first one, make a dot for multiplication, and we're just going to flip these around. So that, by the way, we haven't factored this completely. This could factor to what multiplies to 10 and adds to negative 7. That would be negative 5 and negative 2. Sorry, that's a little bit of a mess here. Let me recopy that above. So 2 times n minus 5, n minus 2, that's going to go to the bottom because, again, we're multiplying by the reciprocal. That's equivalent to dividing by a fraction. And now this thing right here is going to go on top. So we have 3n minus 5 times n plus 1. And now is the fun part, and that's when we get to cancel things. So these will cancel. 3n's minus 5's will cancel. N minus 2's will cancel. 3n minus 5's, another one of those will cancel. These 2's will cancel. So that's 1. I'm just going to put the 1's here to make sure that we've covered everything we need to cover. That's another 1. We still have that n plus 1, so I'm going to rewrite that. We still have this n minus 5. Okay, that's a 1, and that's a 1. These are both 1's, and then we have this negative right here. So let's see what we can simplify this to. So the top is going to be just n plus 1, because it's a whole bunch of 1's times n plus 1. And the bottom is going to be, this whole thing is n minus 5. And then we have this negative right here, and you can decide where you want to put it. But it's kind of negative times that whole thing. So it doesn't really matter how you distribute it, but we'll just see how you can always leave it there. You could distribute it to either. And it looks like they distribute it to the top. So if you do negative times both of those, that's where this negative n minus 1 comes from. But it doesn't matter if you distribute it or where you distribute it, as long as you show that there's a negative there. Okay, this is a similar problem, so let's factor this top part right here. So we're going to have, I'll just do it down below, so we're factoring this right here. What multiplies to 3p squared, 3p times p? What multiplies to 5, 5 times 1? But the 1 would have to go here and the 5 would have to go here. If you try it the other way and you check it using FOIL, it's not going to work. So you start to kind of get better at doing mental math with factoring as you get more practice. But if not, you can use the swing method like we did before. Okay, this lower one is actually the same problem we did on the other page, except it was a minus 11p. So let's just recall where that was. Oh, it was right here. Yeah, this middle term, it's the exact same. So we know it's 3n minus 5 n minus 2 when it was negative 11. So now it's just going to be positive 11. So plus 5 and plus 2. And that's sometimes nice when you can reuse what you already had before. Okay, now times, so we're going to copy dot flop, we're going to multiply by the reciprocal. So that means this will go, it was on the bottom, now it's going to go to the top. And this, let's factor it first. It has a 5p as a common factor. So if we divide this by 5p, we would get 3p. This divided by 5p is 4. But remember, that's going to go on the bottom because we are multiplying by its reciprocal. Okay, so that's what we have there. Now the main event is the canceling part. That's what everybody most enjoys. So let's cancel these. 3p plus 4 will cancel. And we'll just put a 1 times p plus 1 times, and this became a 1. That's a 1. That's a p plus 2. It's often helpful to rewrite this. That's why I'm doing this, because people, when they start canceling everything, it gets messy and they forget. So now all we have to look at this top row. So we have p plus 1 right there. And then the bottom is going to be p plus 2 times that 5p, because everything else is a 1. And we're done right there. I think that's as much as we can do. All right, these are what are called complex fractions. This means a fraction over another fraction. So that acronym, or that saying, copy.flop, CDF is abbreviation for that. That applies right here. We're going to copy this fraction. We make a dot for multiplication, and we flop that. And the only way we can simplify this is 2y, 2 times y over x squared. That's as simple as that gets right there. Okay, this one, same idea right here, so we'll copy this one, x minus 1, it's a 1 right there, over y minus 2, make a dot for multiplication, and then we will flop that. So we're going to get this right here. So we'll have x minus 1 squared, and actually let's just FOIL that out. It's usually that they FOIL. So if you do x times x, you would get x squared minus x, and then minus another x would be minus 2x, and then negative 1 times negative 1 is positive 1. And the bottom is 4 times y minus 2, and you can either leave it like that or you can say 4y minus 8 if you were to distribute that. It looks like they did 4y minus 8. Okay, a couple more of these. So let's do that again. We will copy this part. And don't assume that the 8 plus 2 there will cancel with the 1 on the bottom, because as you can see when we flip this, they're not going to cancel. So that's just something to be wary of. I would not recommend doing these in your head. I recommend writing it out so you can see what it looks like. Okay, if we FOIL out the top, we would get b squared minus 2b plus 1. And if we do a plus 2 times a plus 2, we get a squared plus 2a plus 2a, so that would be plus 4a. And then 2 times 2 is 4. So that is as much as we can simplify it right there. Okay, these ones are a little bit different. Number 11, and we'll stop this video after this problem. We'll pick up in the next one. Number 11 is adding fractions. It's not multiplying, it's adding. And whenever you add or subtract fractions, you need a common denominator. So how do you find the common denominator? Here's how, and LCD stands for lowest common denominator. Here's how I recommend you do it. Basically, it has to cover every part of each denominator here. So what does that mean? Well, a 2 is part of one of these denominators, so we're going to need a 2 in our denominator. We have an x, but we have an x squared. Which power of x would cover both of them? And the answer is x squared. Because x squared, that's 2 x's. That covers this one, and it covers, if I have 2 x's, I definitely have at least 1, so that covers the x part of it too. We also need a 3, because there's a 3 in at least one of them. And then we need a y. So all that stuff that we multiplied right there, 2 times 3 is 6, and then we have x squared y. This is our lowest common denominator. That's how we find it. We make sure that we're covering all the bases there. Okay, I'm just going to rewrite this a little bit bigger so we have more space. So we have 4 over 2x, and then plus we have 3x over 6x squared, over 3x squared y. We need both of these to become that denominator we just found. I keep writing 6 when I mean to write 3. That's supposed to be a 3 right there. Okay, we need it to become this. So let's start with the easy one. What would make this thing right here to be 6x squared y? And the answer is if I multiplied it by 2. And I have to do the same on the top because 2 over 2 equals 1. So it's like you're multiplying by 1. That's fine. It stays the same value. Okay, the question is, what do I have to do over here to make 6x squared y? Well, I need to multiply it by 3 and by x, because x times x would be x squared, and then by y. So times 3xy. That would give me the denominator that we need. Okay, so let's simplify this. So 3xy times 4 is 12xy. And then this bottom we already said is 6x squared y. Over here we know it's going to be 6x squared y. And then 2 times 3x on the top is 6x. Okay, now we can add these over one big denominator because they are the same. We have 12xy plus 6x. Okay, that's not wrong, but it's not completely simplified because if you look at it, there is some factors that they have in common. Okay, so let's pull out from the top the common factor, which is 6x, because 6 goes into 12 and it goes into 6. So if we pull out a 6x from here, if we divide that by 6x, we would get 2y. If we divide that by 6x, we would get 1. And then the bottom is 6x squared y. And now you may notice that there's things that we can cancel. We can cancel the 6's, and we cancel an x here, and we can cancel one of those 2 x's. So our final answer would be 2y plus 1 over just xy. That is as simple as we can make it. So let's verify. We had, what was it, 2y plus 1 over xy, and there it is. Okay, we'll pause there. In the next video, we will do some more practice with adding and subtracting fractions like the ones you see right there.